Welcome to Chapter 7 of Class 7 Science, Heat Transfer in Nature. This fascinating chapter explores how heat moves through our world in 3 different ways. We'll discover why metal pans are used for cooking, why smoke rises upward, how the sun's heat reaches us, and how these principles explain natural phenomena like sea breezes and the water cycle. Through hands-on activities and real-world examples, we'll understand conduction, convection, and radiation, the 3 methods of heat transfer that shape our daily lives and the environment around us. Let's begin by exploring conduction through Activity 7.1. We'll use a metal strip with pins attached by wax and heat one end with a candle. You'll observe that the pin closest to the heat falls first, followed by the others in sequence. This happens because heat transfers through the metal by conduction, the process where heat moves from hotter parts to colder parts through particle vibration. The particles themselves don't move from their positions, they just vibrate and pass energy to neighboring particles. Materials like metals that allow heat to pass through easily are called good conductors, which is why we use them for cooking utensils. Materials like wood, glass, and air are poor conductors or insulators, which is why we use them to keep things hot or cold. Understanding conduction helps explain why wooden handles don't get hot and why woolen clothes keep us warm by trapping air. Now let's explore convection through Activities 7.2 and 7.3. In Activity 7.2, we hang paper cups and place a candle under one. The heated cup rises because the air inside expands, becomes lighter, and rises. This is convection. Smoke rises for the same reason. In Activity 7.3, we use potassium permanganate in water to visualize convection currents. The colored water rises in the center where it's heated and sinks at the sides where it's cooler, creating a circular motion. Convection is heat transfer by actual movement of fluid particles. It occurs in liquids and gases. Unlike conduction where particles vibrate in place, in convection, particles actually move from one place to another, carrying heat with them. This explains many natural phenomena including atmospheric winds and ocean currents. Let's investigate how differential heating creates land and sea breezes through Activity 7.4. We compare how soil and water heat up when placed in sunlight. You'll find that soil heats faster than water and also cools faster. This difference explains why coastal areas experience sea breezes during the day and land breezes at night. During the day, land heats faster than water, so warm air rises over land, and cooler air from the sea moves inland. This is sea breeze. At night, the process reverses. Land cools faster, so warm air rises over the sea, and cooler air from land moves seaward. This is land breeze. This daily reversal makes coastal climates more moderate and explains why houses in coastal areas often have windows facing the sea to catch the cooling breeze. Now let's understand radiation, the 3rd method of heat transfer. Radiation is unique because it doesn't require any medium, it can travel through vacuum. This is how the sun's heat reaches us through space. All objects radiate heat, and when we feel warmth from a fireplace or the sun, we're experiencing radiation. The amount of radiation absorbed or emitted depends on surface color and texture. Dark surfaces absorb more radiation and become hotter, while light surfaces reflect more radiation and stay cooler. That's why we prefer light-colored clothes in summer to reflect heat and dark-colored clothes in winter to absorb heat. A great example of all 3 heat transfer methods working together is the traditional Himalayan Bukhari: conduction through its metal body, convection through air circulation, and radiation providing direct warmth. Let's explore the water cycle and how heat transfer drives this essential natural process. The water cycle is a continuous movement of water through evaporation, condensation, precipitation, and collection. The sun's radiation provides the heat for evaporation, turning liquid water into vapor that rises into the atmosphere. As the vapor cools high up, it condenses into clouds. When clouds become heavy with water, precipitation occurs as rain or snow. Some of this water seeps into the ground through infiltration, becoming groundwater. In Activity 7.5, we test how water seeps through different materials. Gravel allows fast seepage due to wide spaces, sand allows moderate seepage, and clay allows very slow seepage due to tiny spaces. This groundwater is stored in aquifers, underground layers that supply wells and springs. Groundwater is a vital resource facing serious challenges today. Growing populations, excessive extraction, reduced vegetation, and increased concrete surfaces are depleting groundwater levels. However, traditional knowledge combined with modern science offers solutions. Rainwater harvesting, recharge pits, and watershed management can help replenish groundwater. A brilliant example is Ladak's ice stupas, artificial glaciers created by spraying stream water into cold winter air, forming cone-shaped ice structures that melt slowly in spring to provide water for farming. This combines ancient wisdom with scientific understanding of heat transfer and water conservation. The water cycle naturally recharges groundwater when we work with nature rather than against it. Congratulations on completing Chapter 7. You've learned that heat transfers through 3 methods: conduction in solids through particle vibration, convection in fluids through actual particle movement, and radiation through space without any medium. You understand why metals are good conductors for cooking, why convection creates sea breezes, and how radiation explains why we feel sunlight. The water cycle, powered by solar radiation, continuously redistributes Earth's water through evaporation, condensation, and precipitation. Groundwater stored in aquifers is replenished through infiltration, and traditional innovations like ice stupas show how we can work with natural processes. Remember these principles in your daily life: when you cook, feel a breeze, or see clouds forming, and appreciate the beautiful science of heat transfer in nature.